Okay, this video is going to talk about increasing, decreasing of a functions and how that relate to local max and local min, and how that helps us to find a function using antiderivative. So this is an introduction to antiderivative. All right, so let's say a function is increasing, as we all know, is when the derivative at the point um, is a positive number, and the function decreasing when the derivative at the point is a negative number, right? So to find the local maximum, we need to find a critical point. That don't forget that the critical point is when the derivative is equal to 0 or undefined. Okay, so you can set that up. So critical points to find C, to find critical point C, critical point C. C is when the derivative of a function is equal to 0. Okay, so we know that. So now at the critical point, if the function is increasing on an interval that is smaller than the critical point and then decreasing on the interval that is larger than the critical point, then we say that at the critical point there's a local max. Okay, the similar to local min, if the interval that is smaller than the critical point is a negative number, which means decreasing, and the interval that is larger than the critical point is a positive number, which means increasing, then we say at the critical point there's a maximum. Okay, so so let's say if the problem is asking you to, if the problem given you that f prime of a is equal to 0, right? Then that must mean that at x is equal a, this is a critical point at x equal a, right? So that means that f prime of, we can write that x minus a is equal to 0, right? So we have the f prime of x function here, right? Because since we know f prime of a is equal to 0, and that means that the critical point at x equal to a, then that means that if you subtract both sides from for a, then we have what we just wrote here, x minus a is going to be equal to 0, right? X minus a equal to 0. And that's the same thing as we said here, that is f prime of x is equal to 0, right? So we can say that the derivative, if we say that f of a equal to 0, meaning that the derivative is equal to 0. Now, since you have the derivative, you can think, okay, so once you have f prime of x is equal to x minus a, what functions would give you, which function can you think of would then, when you take the derivative, then will you have x minus a, right? So so the functions, the things, so we know that if f prime of x is equal to x, right, then the only functions that would give us the derivative like this, don't you agree that if that's only happen when f of x is equal to x squared divided by 2, right? Because when you take the derivative of this, you minus 1 from the numerator, right? So that brings the 2 down, and that gives us x. Okay, so and another one we know f prime of x is equal to a, and the only function that would give us this is f x is equal to a times x, right? Because the derivative of a times x with respect to x is a, right? So since the derivative of this is x minus a, that means the function of x is going to be x squared divided by 2 minus ax. Right? We can double check by take the derivative of these functions, we'll get that. Right? So you could think about that way, or you could think if the problem is asking you for, let's say if you have a local max at x equal to 4, right? Since we know the local max at a point is, that means that the critical point is x is equal to 4, right? So that means that f prime of 4 is going to be equal to 0, right? Because the critical point is when f prime equal to 0, right? So therefore, we can think of it, since x equal to 4, you can think of it as subtracting 4 from both sides. That means that x minus 4 is going to be equal to 0, and that is f prime of x, right? So you can think your functions is f prime of x is going to be equal to x minus 4. And which functions would you be able to look at and find the derivative such that the derivative is x minus 4, which is that is f of x is equal to x squared over 2 plus minus 4x, right? Because if you take the derivative of this, you get this. Okay, so hopefully this will help.